set up a one-to-one correspondence between these two sets. When setting up a one-to-one correspondence, we want to find a formula that will generate this entire set. So I'm going to do this by looking at successive differences. If we write out the first few elements of the set, 2, 5, 8, 11, 14, if we subtract these two, 5 subtract 2 gives us 3, 8 subtract 5 gives us 3, 11 subtract 8 gives us 3, 14 subtract 11 gives us 3. This is a good sign. We have the same number every time. We had to do one level of differences. We'll see what might change if we have more than one level of differences. We did a single difference. That says we're going to look at something like n to the first, one level of difference. And because we have a 3 as this constant here, it's going to look like 3n to the first. Or if we simplify this, 3n. Now we may have to fiddle with this a little to make it match up with what our set is. So if you plug in the first few numbers for n, if you plugged in n equals 1, 3 times 1 is 3. If you plug in n equals 2, 3 times 2 is 6. Plugged in n equals 3, 3 times 3 is 9. Plug in n equals 4, 3 times 4 is 12, and so on. If you compare this with the original list of numbers, 2, 5, 8, 11, these are all just one more than the set that we're looking for. So if we just subtract 1 from all of these, if we change our formula to 3n subtract 1, this turns our list into 2, 5, 8, 11, and so on. And so that matches. That says the general term for this will be 3n subtract 1. Now we can do the same thing with our second set. 3, 6, 11, 18, 27. We subtract these two, we get 3. If we look at 11 subtract 6, that's 5. 18 subtract 11 is 7. 27 subtract 18 is 9. I notice these are not the same as I go through. So we'll try it again. We'll look at another layer of differences. 5 subtract 3 is 2. 7 subtract 5 is 2. 9 subtract 7 is 2. Now this is a good sign. The fact that we have the same number all throughout here says that we had to do 2 layers of differences. On the previous sequence, we had to do 1 difference, so our answer looked like n to the 1. If we do 2 layers of differences, this should look like n to the second divided by 2. And then, because this number that we had all throughout here is 2, that says we're going to multiply this whole thing by 2. We can simplify this by canceling those 2's out to just n squared. So let's test this. Let's look at the first few numbers for n. If we plug in n equals 1, 1 squared is 1. If we plug in n equals 2, 2 squared is 4. Plugging in n equals 3, 3 squared is 9. Plug in n equals 4, 4 squared is 16. Plug in n equals 5, 5 squared is 25. We want to compare this with the original set. The original set was 3, 6, 11, 18. We have 1, 4, 9, 16. We can fix this by just adding 2 to every one of the elements of our set. If we add 2 to 1, we get 3. If we add 2 to 4, we get 6, and so on. That says we need to adjust the formula that we found by adding 2 to every term. That tells us that our general formula for this will be n squared plus 2. So then our one-to-one correspondence between these two will be the formula 3n minus 1 corresponds with the formula n squared plus 2. And that gives us our one-to-one correspondence.